Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT, here from Weather Risk, your commander of chaos, your colonel of confusion, your captain of catastrophe. Let's talk about This Week in Weather. And I wanted to get this out much earlier. Unfortunately, it's about midnight now here, Wednesday night, going into Thanksgiving morning. There's just so much weather to talk about, really exciting stuff here. This slide presentation is like 40 slides long, so a lot of graphics to it, so that's going to help understanding, but there's a lot of weather to talk about here. It's really exciting if you like winter weather in the central and eastern United States and you like cold temperatures, so let's get right to it. First, as we have pointed out on the Facebook page and also over on some other social media platforms, Blue Sky, the final my final outlook for this winter is out for the 25-26 winter. So a couple of minor changes to it, just some also new information there. You might want to take a look at that. It's pretty interesting. Really, the worm has turned. The mild pattern has come to an end, and we're now heading deeper into winter. And it's going to get pretty darn interesting here coming up over the next 2 or 3 weeks. We have a first significant Midwest snowstorm coming on Sunday. That's a doozy. There are places in Iowa and northern Illinois they're going to get 10, 12 inches of snow out of it. Widespread 5 to 12 inch snowfall, really. And also impacts southern Minnesota, southern Wisconsin, a lot of Michigan, northern Illinois. Chicago's going to get clocked. So a nice snowstorm there. And then we have our first one on the mid-Atlantic for December 2nd. In New England. That looks interesting. Now, of course, it's a little early in the season for the coastal areas there, and the ocean water temperatures are still very warm, but it's something. And then, of course, the MJO heads into phase 8, December 7 to 14, depending on which projection you're looking at. And the pattern is very active, and I'll show you what I mean here. And this kind of active weather pattern, you can expect a lot of sudden, dramatic model flip-flops. And you can see that. I mean, the December 2nd system wasn't even there 2 days ago. Now suddenly it's there. And finally, I want to talk about a new teleconnection, a new pattern that you may not be aware of called the ABNA, the Asian Bering Sea North America teleconnection. So this is the website, as you can see. And there is a shop page, our snow removal forecast. You can still get it, snow removal here. We cover a lot of the Mid-Atlantic here in great bit of detail. And then also you can get the Mid-Atlantic forecast, which you can see here, which comes out every other day. And it's got your temperatures and rainfall, precip and maps. It's only $35 a month. This here is the weather is grain page, and this here is the Blue Sky page. All right, let's get right to it. So this is the current upper air map here on this Wednesday evening. There's the major trough coming through. You can see the bombing. This system is bombing out very nicely here in the Great Lakes. It really blew up in Minnesota, Wisconsin, dropped the heavy snow there. And now it's bringing in the Arctic air. There's the first cold front here, and there's the second one right behind it that's bringing in the really cold air, starting on the East Coast on Thanksgiving Day. The temperature may actually only go up a few degrees on Thanksgiving Day, then fall rapidly during the evening hours. And of course, the Arctic air coming in here is going to produce a tremendous early season. Well, not really early, but a major lake effect snowstorm for the snow belts in the Great Lakes. All right. So then the trough, of course, amplifies and becomes quite deep, as you can see here. It develops a negative tilt on the East Coast, very intense cold air convection. Look at these howling northwest winds here. Winds up to 30 miles per hour from in the Great Lakes and northern New England, maybe 25 in the Mid-Atlantic and the Ohio Valley. The Arctic high is coming southward. Very nice pressure gradient here. And this is Friday morning. And these winds are really coming in and pulling the cold air in. The other thing I want to point out is here on the upper air map is look at the additional shortwave energy coming in on this very, very active pattern. See this shortwave here, another one here, and another one here. This is going to be a constant feature over the next 2 weeks, all this energy coming in from the Pacific. Now, then, of course, by the time we get to Saturday, November 29th, here is our Midwest snowstorm. This trough comes down, drops from Canada, and it becomes neutrally tilted in the Rockies. And whenever that happens in the Rockies or the Plain States, in the winter months, that produces significant low pressure in the Midwest. And if the air mass is cold enough, you get a snowstorm. And that's exactly what happens here. Meanwhile, on Saturday morning, the Arctic high is centered right over Virginia and Kentucky and the Ohio Valley, and it's the coldest morning since last winter. And you'll see that in a little bit. The winds begin to die down the Great Lakes. The lake effect snow is reduced. You're still getting some snow showers in upstate New York and northern New England. But look at this major snowstorm developing here from the upper plains. And here it comes. Watch this monster go. Now, these are the temperatures. I want to show you these temperatures for Saturday morning. So this is going to be the coldest morning. Now, this here is, let me bring this forward so you can see it a little bit. This is here the Mid-Atlantic region here. And you can see, 20 degrees in Richmond on November 29th, no snow on the ground. That's impressive. Yeah. Okay. And then you got teens in the Shenandoah Valley. You got low 20s in much of North Carolina. Wow. November, that's impressive. I'm really freaked out over West Virginia. Look at these temperatures, Ohio. Interesting enough, Pennsylvania and New Jersey are not nearly that cold. And then you can see this on the regional map. I'll bring this forward, and you can see it here. And look at the regional map right here. You can see the coldest, oops, that's not what I wanted here, my marker here. No, that's what I want to get rid of that. You can see the coldest temperatures are clearly in the Ohio Valley and down to North Carolina and Virginia. That's the heart of the coldest air where the winds drop off and right in that area. Not quite that cold in Pennsylvania, New York State, or New England. Okay, now, as we come out of, as we go into the medium range forecast, let's want to point out here, this is the European model from November 23rd. That's only 4 days ago. Well, 3 days ago, if you're going from the 26th. And this is valid for November 30th. And look what it was showing. It had two short waves here, one in southwest Canada, the other one in the Rockies, and they merged them into this gargantuan long wave trough and developed this massive ridge for Thanksgiving weekend up and down across the Midwest and the East Coast. That was November 23rd. Now, as you can see, this is bullshit. That's reality. That's what it was showing a few days ago. So what I'm telling you here is that you have to be careful with the models. They love to bring this energy down the Rockies and into the south, into the western United States prematurely. So just be careful with that over the next 10 or 12 days. All right. I thought that was kind of interesting. All right. Instead, this is what happened on November 29th. Not this, but this. So we have another short wave. This is the Midwest snowstorm. There it is, really bombing out and slamming the Midwest with a major snowstorm. But look at the additional energy. There's another short wave right here in Idaho and another one off the California coast. So this has to be watched for the next system. But here's the Midwest storm ahead of the highs moving off the coast. We're getting southerly winds developing over the deep south. Here's the snowstorm. This is the European model. This is the national blend of models, which is very reasonable to use. And you can see, look at that, over a foot of snow in portions of Iowa. Wow. Chicago, 9 inches. Rockford, 11 inches. Milwaukee, 11 inches. Green Bay, close to 10. I mean, this getting blasted. South side of Minnesota, 6 inches. North side, 3 inches. It's a big snowstorm. No doubt about it. Central Illinois gets hit. And now, of course, some of this in the northern Great Lakes is lake effect, but most of this is the snowstorm. All right. Let's talk about the La Nina. It is weakening. Finally, we're seeing big changes here in the SOI. Some other areas, it's changing nicely. Let me call it a good marker here. I thought I had one saved, but I guess not. And you can see developing very nicely here. There it is. It's coming up. I think it's coming up now. Maybe it's going to drop down again, but like I mentioned before, and I've said this for weeks, there is very strong data that shows La Nina is going to come to an end in December, by the end of the month. We'll see if that happens. Okay. Now, many of the forecasts, private, government, still have La Nina hanging on through a good portion of winter. But again, the data tells me that's bullshit. It is going to come to an end by the end of December. We'll see. Maybe I'm wrong, but that's what I'm sticking with. Meanwhile, the southern stratospheric wind, you can see we've reached our peak here, negative neutral values here. So we now have a sudden stratospheric event is underway. and then of course it rises. Now the thick red line is the mean, and then look, it drops down again, and by the time we get to mid to late December, there may be another weakening of the vortex here in mid to late December. So that's interesting. But you can see that most of these lines stay below the mean, which indicate for all the way into January, potentially a weak polar vortex, which means more negative Arctic oscillations and more blocking and a much more active and stormy winter potentially coming up. All right, let's talk about the MJO. Now, this is the latest trace. And what I wanted to show you here is look how it's been stuck in phase 6. See this? And then when phase 5, look how it's stuck in phase 5. And now it's stuck in phase 6. And as we look at the projections, you'll see it getting stuck in phase 7 and stuck in phase 8. That's what's going on with this particular impulse of the MJO. It's doing these long movements where it gets stuck in phases instead of just like, well, back here with phase 2 and phase 3 was just ripping along. Phase 2, phase 3, phase 4, and 5, whoop, getting stuck. 6, whoop, getting stuck. 7, whoop, getting stuck. And look, I'll show you. Here are the models. Okay, here's the European coming out of phase 7. It goes into phase 7, then it does look, another look right here in phase 7 going to phase 8. Here's the CFS. It does a loop-de-loop in phase 7, then it goes into phase 8. Here's the Australian model, corrected also for bias. Look, another loop right there in phase 7, and then it does another loop in phase 8. That's what it's doing. Now, what does that mean? Well, this is phase 7 in December. Now, phase 7 in December, as you can see, is generally a colder pattern, but it also has a ridge over the southeastern states from time to time. And we have the negative anomaly over New England and southeastern Canada. So what you end up getting is a battle zone. When the ridge is weak, the northern jet comes southward. You get some snow and ice and mixed precipitations. You get a lot of waves of low pressure developing on the front over the southeastern states. And that's what we're going to see on December 2nd and maybe on December 6th. But it doesn't last because the ridge is still there. So it's kind of an up and down, back and forth pattern here. And you can see that's exactly what happens here on phase 7. It is much colder in the Midwest. Now the East Coast is cooling down, but it's not really that cold just yet. Now when we go into phase 8, now we're in a different ballgame, boys and girls. Now we have a significant block developing in Greenland and the northwest Canada. We have a strong negative anomaly over the northeastern U.S. The southeast ridge is gone, and we have a winter storm pattern with temperatures below normal for everybody east of the Mississippi River. This is a great pattern if you like cold and snow in the Midwest or the East Coast. This is a great pattern. Now, in the event that the La Nina actually dies and breaks down in late December, then you get this. Now this is the ultimate snowstorm signal for December. Phase 8, MJO, neutral conditions. See this? Neutral ENSO. See that right there? Neutral. Monster block in Greenland. Very strong negative anomaly over the East Coast into the Northwest Atlantic. This is snowstorm, big time, if that happens. Now, we don't know that. Okay, this might not happen until January. But if it does, in late December, it could be very, very interesting. All right, let's talk about teleconnections. We have our two on the Pacific side, the EPO, Eastern Pacific Oscillation, the PNA, the Pacific North American, and the Atlantic side, the Arctic Oscillation, go negative or positive, and the NAO, which again has neutral, negative, or positive phases. So if we look at our Pacific side, you can see that the EPO, that's where it has been. It's been dropping down. It goes neutral. It goes negative here into December. Then the GFS model, the red dots, has it going positive, but the other models have it staying either neutral or negative. Here on the PNA pattern, which is the West Coast Ridge or West Coast Trough, it's neutral, as you can see. Then it drops down a little bit negative as we go into the middle of December. On the Atlantic side, the Arctic Oscillation, as you can see, it's very close. It was slightly negative, then it was positive, now it's back to neutral, and it stays pretty close to being neutral all the way through. And then the NAO, same thing. We're slightly positive, then we're neutral, slightly positive, go back to neutral all the way through into mid-December. So in other words, the teleconnections are not really driving the pattern that much. It's really the polar vortex and the MJO, which is really driving the overall pattern. And the teleconnections aren't very amplified right now at all. Okay, let's talk about what happens after the snowstorm. So there's the Midwest snowstorm pattern. The major trough swings through. You can see the trough here. All right. It swings through the Midwest and the East Coast. Now there's another short wave here. You can see this over the Rockies and another upper low off the California coast. There's your ridge bringing in the Arctic air. You can see the lines coming out of Canada really pulling in the Arctic air. So this is another nice cold, very cold air mass. The cold front arrives. We get rain showers on the East Coast into New England, and then behind it, another blast of cold air. This is November 30th. Okay? Temperatures ahead of their front may be in the 60s on Sunday. So if you want to get out of the house and do stuff, Sunday, November 30th might not be a bad day to do that. Okay, now we get to December 2nd. So we talked about these two pieces of energy were going to merge, and sure enough, that's exactly what happens here. This is now the night of December 1st and 2nd. Look at the long wave trough. You see the line here? That's your trough axis. See how it's positively tilted, running northeast to southwest, right? There's your polar vortex. It's very strong, and it's fairly far to the south. It's in Hudson's Bay. Normally, the polar vortex is way up here. So you can see it's pretty far to the south, and it remains that way. And there's December 3rd. When the polar vortex is this far south, it introduces a lot of cold air, so the temperatures are below normal, and this piece of energy swings around. We get a little bit of a negative tilt here over the southeastern coast and some kind of low pressure. So the front, when it comes through, this end of the front's going to stall right here, all right? And then this energy is going to catch it, and you're going to develop your low pressure. There it is. Here's the European model. This is the 18Z European. The low develops here, a lot of rain in the southeast, and there's a big drought here, by the way, if you're not familiar with that. So this is going to be nice rain for them. And the rain goes up into the Carolinas and eastern Virginia. And now the European has the snow further north. And this makes sense. It's early in the season. The ocean water temperatures are very warm. So this is an interior, in my view, mid-Atlantic snowstorm, if it's going to happen like this. So maybe the Shenandoah Valley will catch some northwest Virginia, western Maryland, but this looks like, to me, mostly a Pennsylvania, northern New Jersey, maybe New York City, New York State, and New England snowstorm. But even on the coast of New England, it could go over the rain. This here, now that's the European. If we look at the European ensemble, this is very different. It is flatter, it is colder, by far, as you can see. Now the thick black line here, this is the 850 temperatures. Okay, 850 millibar temperatures. In other words, 1 mile above the ground. That's the rain snow line. And forecasters use that line as a guideline. There are other ones you can use, but that's one of them. And so if the atmosphere is below zero, 1 mile above the ground, and it stays below zero, well, I'm talking 32 degrees centigrade, 32 degrees Fahrenheit or 0 degrees centigrade, all the way down to the ground, it stays all snow. See that? It stays all snow here. Now this is all rain. So it's rain. Then you have this little mix right in here. Okay? In western North Carolina, maybe Richmond, Delmarva. And then north of that, D.C., Charlottesville, Winchester, Harrisonburg, maybe Roanoke a little bit up. And then it continues up into eastern Pennsylvania, New Jersey, and New England. And the gray area also is light to moderate precipitation. So this is not a big deal. This is not going to be a big snowstorm, according to the European ensemble. Now the GFS is going bonkers. This is the 18Z and wraps the low up into eastern Virginia. So it drives the rain snow line way north into central Pennsylvania and northern New England. Boston is rain. New York City is rain. Philly is rain. Okay, Harrisburg is rain. Charlottesville's rain. Winchester's rain. Hagerstown rain. Now this is a very wrapped up system. I'd be surprised if this is correct. Indeed, if you look at the GFS ensemble, no. Look where the low is. It's way out here. It's not over in inland. It's way out here. This is a much colder solution. So I think this is bullshit. This is just too wrapped up in here. We'll see. I could be wrong, but this looks like it's way too wrapped up. Way too wrapped up. Okay. Let's go beyond that and see what's going on. All right. After this December 2nd system here, here comes the next threat. This is December 4. The polar vortex, again, is very far to the south. Notice the southeast ridge is way, way down in Cuba, so that's good. And here comes the next short wave. Okay, it comes around, drops down, here goes to the southwestern states, and it begins to swing around, and you have this little disturbance. Let me blow this up for you. You can see it right here on December 5. See this little disturbance right here, the little kink in the lines? That's a short wave, and there's another one coming in behind it. There's your ridge on the west coast. We're getting some blocking showing up in Greenland. That's interesting. And the polar vortex is in eastern Canada. So that means these systems are going to stay to the south. They will not. The polar vortex blocks them from coming northeast. So these pieces of energy will stay to the south. And we look at the maps, we can see this system really amplifies here, and we get this nice trough for December 6th, and the European ensemble, the AI, is really scary looking. That's a pretty significant trough here, and that's a lot of cold air. And there's more energy coming down from Alaska. So you see how the energy just keeps coming down and dropping into the mean trough here. So as a result, here's the European, the next system for December 6 or 7. It's snow in Virginia and Maryland, southern Pennsylvania, and the GFS has it as well. Also has some rain in North Carolina and southern Virginia, but it's a mixed thing. And again, this is early December. This is very early in the season for this kind of activity in the southern mid-Atlantic. But it's an indication what I think is going to end up being a pretty significant winter. So that's why I'm encouraged about this. But if this AI model is right here, that's a pretty impressive looking trough. But even if it's not, again, this is also pretty decent, the regular European. And again, look at the energy coming down from Alaska. See the shortwave here, another one here, and then another one here. And look at how large the polar vortex is placed way to the south. I'm telling you, this pattern has got all kinds of potential. All right, as we go into 11 to 15 day, we're at it again. Look at this map. There's another short wave moving through the Midwest, about to swing towards the East Coast, and more. Look at the energy. One in Alaska, British Columbia, Minnesota, and then somewhere in the Mississippi Delta. Bada boom, bada bing, bada boom, bada bing. And here's the blocking. I'm telling you, this got all sorts of potential in this pattern. Really looks very impressive. Now this implies, if this is right, something December 10 or 11, maybe. So now if you look at the ensemble, it's not nearly as aggressive. The ensemble is much broader, as you can see. Let me bring this forward so you can see it. All right. And let me bring this one forward, this too. See, there's your polar vortex, which is huge, very large, very powerful, and it's pressing southward in all directions. And all the ridging is way to the south. This is a cold air mass. Look at the flow coming out of the North Pole and over Siberia. Look at the flow, pouring right down into Canada and then driving southward. If the polar vortex continues to drop this far south, it's going to get really, really cold. And this storminess potential increases significantly. So this has got all kinds of potential here for December 7. And then we go beyond it. This is the European for December 9-10, and there's even beyond that. If this is by day 15. This is just a cold pattern. Now, none of these maps look particularly stormy, but these are ensembles. I don't know. This is so much energy coming in here on the jet stream. These little short waves are being washed out, or they become lost in the noise in the overall pattern. So again, even though this does not look like a particularly threatening pattern, it might be. And of course, the European AI seems to be picking up on this a little better because, again, it's got a nice trough here in the Midwest, December 11. It's got potential. Okay. Now, finally, I want to talk to you about this new teleconnection. This is the panel. This is the paper came out in 2023 about a new teleconnection called the Asian Bering Sea North America, or the ABNA. All right, and this is what it looks like in general. So what you have is you have the big negative anomaly in Siberia. Then you have a positive anomaly in eastern Siberia to Alaska and the northern Pacific, and that produces a big trough over the eastern United States. So it's That's what the connection is with it. So we get negative anomaly in central Russia and western Siberia. Then you have this big positive anomaly here in eastern Siberia and Alaska, and it sets up. It's similar to a cross-polar flow, but a little different. And one of the things that helps determine it are the sea surface temperatures. So as you can see here, as we go into November, December, January, and then December, January, February, you have this pool of really warm water in the central and eastern Pacific, and then the cool pool to the west. And this kind of sets up the overall pattern. You can see it setting up here. This is the sea surface temperature map from November 19th. And it looks very similar. And again, also notice that you have La Nina here, weak La Ninas. And again, that's exactly what we have with the sea surface temperatures. So this has some similarities to what we're seeing. Of course, this is a textbook definition. No sea surface temperature map is going to look exactly like this, but you can see it looks pretty good. Another thing that helps bring about the ABNA pattern is the measure of the snow cover in October and November. So the purple lines and the black lines, the areas that we look at in snow cover for October and then in November. And the thing over here that you look at are the anomalies. So in November in particular, when you have a significant negative snowfall anomaly in western Russia over into Kazakhstan, and heavy snow cover in southern Siberia, Mongolia, northeastern China, that really gives off a signal for a potential ABNA pattern. And this is the latest snow cover map, and you can see this is from Rutgers and this is from the National Ice Center. You see the negative anomaly here in western Russia and Kazakhstan? That's exactly what the ABNA triggers an ABNA pattern. So we could be looking at that. And if this happens, this is going to lock in for most of the winter. And it's going to help ensure a colder than normal winter and potentially a stormier than normal winter in the central and eastern U.S. Now, again, this is kind of speculative, but that's what we're looking at. And I think this is an important teleconnection. I think people need to know about it a little more. So I wanted to spend a few minutes talking about it. But as you can see, it's got some similarities to what the research shows. And in particular, the snowfall cover anomaly looks very, very close to what we typically see in November that triggers the ABNA pattern. All right, that's the end of the presentation. I know this is a long one. I'm sorry about that. I'm going to have to figure out a way to do shorter presentations, but when I do the This Week in Weather, it goes on for a long, there's a lot to cover because I only do it once a week. Anyway, this is meteorologist DT from Weather Risk. Happy Thanksgiving, everybody, and we'll catch you next week.